So I just got my kit, my motor kit, and it's time to put it together. Let's see what we got here. Boy, that's a lot bigger than I thought it would be. This thing it's huge. Boy, that must have cost a lot. Whoa, wait a minute, that's not the package. Oh, there it is. Now that's a little bit better, that's more like it. Well, let's take it over here and do an unpacking. Open box, so to speak, to see what we've got here. Now, I've got this nice little workstation that my grandkids use, so here I am. I'm gonna sit down here. Oh, I can't wait to open this kit up and see what I've got. Let's see here. Whoa, what was that? That's a piece of copper wire. What else have we got here? Oh, look at all this cool stuff. All right, let's see. We got a, we got some alligator clips here. I got a yellow one and I've got a green one. Okay, what else? Oh, here's a battery holder. Not quite sure what that's going to be used for yet, but we'll see. Here's that piece of copper wire that fell out. Interesting. And then I got a little piece of cardboard with something taped to it. Let's see what that kind might be. Ah, yes. That is a magnet. If you don't believe me, this magnet can actually hold up this piece of cardboard just by touching this piece of... Oh, and look, there is a piece of metal tucked into the cardboard. So let's go ahead and take that out. We're probably going to need that. In fact, I'll just tell you right now, you're going to need everything. The cardboard, even the blue tape. So don't throw that away. You'll probably want to use that in a second. So I'll pull these little two pieces of silver wire out. Put those over here. All right, now, in addition to the these things that came in the envelope, you're also going to need a couple of tools. So let's go over that. I've got them laid out right here. So a pair of needle nose pliers will be very helpful. You saw the battery holder, so batteries are not included. You're going to need a battery, and it'll need to be a AA battery because that's the type of battery holder I sent you. And you're going to need something sharp that you can just scrape some insulation off one of the wires. You don't really have to cut anything. So any kind of sharp razor blade type thing, you can have a box cutter, you can have an X-Acto knife, but something sharp, even a sharp kitchen knife. Okay, so let's get started here. I've got some wires here that will attach themselves to the magnet if you're not careful. What we're going to do is, first of all, we have to make the rotor part of the motor. So to do that, I'm just going to straighten out this copper wire. Should be about 2 feet long. And I'm going to wrap it around to make a nice tight coil around this battery. And I want to leave myself just a little bit of room on the end. I don't know if you can see that better with the cardboard behind it, but anyway, you'll see why in a second. So give yourself a good 3 or 4 inches and then just start wrapping it around the battery. It doesn't matter if it's overlapping or anything else. Just want to make a nice tight coil and leave yourself about that much at the end. So now I've got a nice tight coil. Now this is the kind of tricky part here. I need to be able to cinch that coil up so that it doesn't move. So the way I'm going to do that is I'm going to take one end of the wire and basically tie a little knot. So I've got that tied in a knot now. And so when I pull this piece, and this is where the pliers come in handy. So I'm going to pull this really tight, make a nice kind of wiggle it back and forth. And now you see I've got a nice tight little, let me move this out of the way so you can see it better. Okay, now I've got one side done. Now I need to do the same thing on the other side, but I need to make sure that it's exactly on the opposite side. So I'm going to go around again, tie a little knot, grab my pliers, and pull nice and tight on this side, but I want to make sure it's exactly opposite the other side of the coil. That looks pretty good. We can refine that if we need to. And you notice that I've got now a good couple of inches of wire on either side. So that should be, and if you pulled it in your fingers, just balance it. It should be really easy to turn around in your fingers. Okay? That's going to be our rotor part of the motor. All right, so the next thing we need to do, we'll just put that down for a second. The next thing we need to do is make a place for this rotor to actually sit in. To do that, this is where the pliers will really come in handy. And we're just going to make just a little bit of a coil on one end of the wire. Just a little loop. Okay? Doesn't have to be anything fancier than that. The wire from the rotor is going to go inside this little loop. So as long as it is big enough to go inside there. Now the rest of it is going to actually be our little stand. So I want to get this nice and straight so it can go vertically down. And then about 1.5 inches or so down, I'm going to make a bend. Just so it has enough so it can actually sit on the ground more or less. Okay? Now we're going to take our piece of cardboard and we're going to poke this right through the cardboard from one side. Okay, so I'm going to poke it through, and now I've got this little coil. I'm going to turn it this way so that it actually faces this direction. And then on the back side, I'm going to take it and I'm going to bend it around a couple of times just to make sure that it will stay vertical. And this is where the tape comes in. So take one of your little pieces of tape that came with it and just tape that down. That way it'll stay nice and flat. If it's not staying flat enough for you, just bend it so you can even poke it back into the cardboard if you want. Sometimes that helps it stay down. So if I just poke it back into the cardboard and then put the tape on. Now this wire that I've put in from this side is poking straight up and is going to be one side of our motor. See how that works? All right, so we're going to take the other one and do basically the same thing. So I'm going to take and make a loop at one end. Okay, so that looks good. Nice little loop. And I'm going to bend this straight. Now the tricky part here is I want this to be exactly the same height above the cardboard as the other one. Again, we can make small adjustments later on, but we want to get it basically bend it right about there. Okay. Now I'm going to poke this through the other side of the cardboard. And I want to make sure that these things are apart. I want the coil to be in about the middle. So, and have a little bit of leftover to poke through the rotor from the other side. So that's about where I want the second support to be. So I'm just going to poke this right through again. Poke it all the way down. Make sure that it's oriented so that the rotor can actually be lined up between the two. And then I'm going to make a couple of bends over here. Try to keep them spread apart and flat so that when I put the piece of tape on them, it will hold that thing vertically. No, not quite right. There we go. Something like that. Okay, I'm just going to bend that a little bit. Take my other piece of blue tape that I saved and tape that one down. Make sure it's nice and firm. And now what do I have here? And if you look, I actually did a better job on the second one than the first one. You're always going to do a better job on one of them. But the important thing is that now these are, both the little loops are pointing in the same direction. So I can now insert my rotor right through one end and then back through the other one. And now my rotor should be suspended between the two supports. Now, if you look at this carefully, you'll notice that one support is definitely higher than the other. So what am I going to do? Well, I want this to be as perfectly level as possible. The easy way to do that is just to bend one of these down a little bit. So if I bend it down, now it's not as tall as it was. So if I bend it way down and then maybe come back again and bend it back up, now I can control exactly how tall this one is on this side. I can get it much closer to being the same level. So I'm going to do that and just kind of play with that a little bit. See if I can get this more or less at the same level. Oh, that looks a lot better. Now if I spin it, which is what the motor is going to do, this thing is going to start spinning on its own. I want to make sure that it's more or less balanced. All right, let's go with that for now. We can adjust it later on if we want to. Now the final step is going to be putting the magnet underneath this motor. And it doesn't matter if it goes like this or if it goes like this. This actually is a little bit easier to move the magnet around. So we'll just do it like that. Now you notice that my magnet is about a ½ an inch away from the rotor. You don't want the rotor touching the magnet. You want it to be just suspended just barely above it. Okay? So we'll take that out for a second. We got one more thing we need to do, which is we have to remove the insulation from this wire that makes up the rotor. Now you probably didn't notice it, but this actually is coated with a varnish type of plastic material so that it will not, it's like an insulated wire. It looks copper because the coating is actually clear. But we need to remove that coating, and this is the critical part now. You need to remove the coating only on the top of the wire. You want to leave the insulation on the bottom part, but remove it on the top. That's what the razor blade's going to be for. So we're going to take this wire, and I'm going to go over to the edge of my table so I can hold, back up here a little bit, and maybe zoom in so you can see exactly what I'm doing. So I'm going to take my, in this case, a razor blade. Now when you do this, make sure that you're holding the rotor vertically. So when you put it against the table to scrape off the insulation, make sure that rotor is vertical, not horizontal like that. If you do it that way, you'll remove the wrong side of the insulation, and then the motor won't work right. So turn the motor so that it's vertical compared to the table, and then you're going to go back and scrape off the insulation on one side. Now you can be a little aggressive here. You can take off just a little bit more. I kind of turn the rotor a little bit like this as I scrape. I want to get the insulation off over 180 degrees of the wire diameter. Okay, so if that looks good there, I'm now going to turn the rotor around, and do exactly the same thing on exactly the same side to the other side of the wire. Now it's important that you don't mix it up and do this side of the wire. It's got to be the same side of the rotor that you did for the other side of the wire. Okay, and I'm kind of just turning it a little bit so that I can get all the insulation scraped off. Okay, let's see if that's enough. I always like to come back and do more if I need to. All right, so now we have the rotor. We scraped off the insulation off one side of it. And we're going to put it back in our, let's go back over to here. And we're going to put it into our supports. And this is where you want to try to get it as balanced as possible. That means these wires have to be coming and going straight in both directions. The straighter they are, the better your motor will spin. If you spin it like this and it kind of wobbles a little bit, try to straighten that out. Try to get this as straight as you can. Try to get the rotor right in the middle. See, that's spinning much better now. Okay, now that we have that, we're ready to actually plug our battery in. Now, some of you got single battery cells, some of you got multiple battery holders, like this one. I only want to use one battery, but I didn't have the battery holders, the single battery holders, so I sent you whatever I had. Now, if you'll notice, one wire comes out of the battery connector, the battery holder right here at the positive end. The other is actually connected to the negative side of this battery holder or on this end. But we don't have 4 batteries. I mean, if you have 4 batteries, I suppose you could use them, but we only need one. So what I'm going to do instead, I'm going to fake it out. I'm going to take the red wire is connected to the positive end of the battery right now. So I'm going to take my green alligator clip and just clip it right into the wire on the red side. So now I've got a lead that I can plug in, or I can attach to the positive side. Now, what do I do with the negative? This negative is not going to do me any good because there's not a series of batteries going back and forth. So I'm going to trick it. I'm going to take my other alligator clip and I'm going to just attach it right there to the spring that's compressed on the other end of the battery. That's now the negative end. So what have I got here? I've got a negative battery. That's my yellow wire. Whoops. I seem to have 2 actual yellow wires in that kit. Okay, so this end of the wire is now negative, and my green end of the wire, this end, is connected to the positive side of the battery. So what I'm going to do, let me back out here so we can see it a little bit easier. What's going on? I'm going to connect the 2 ends of my battery. I'll just put the battery up here so you can see it. And I'm going to connect one side to the positive support, and I'm going to connect the yellow side, which is my negative, to the other side of the support. If I can get in there. There we go. Now, by putting a magnet right here, I should be able to start spinning my motor. And let's just think about what's actually happening here. Get this wire out of the way. All right, so what's happening? You have electricity going from this side into the copper coil and then coming out over on this side. That means electricity is flowing through the copper coil. As it turns out, electricity has magnetic properties. If you can get electricity to flow through a wire, you'll create a magnetic field around that wire. If you have the wire coiled up like I do, it actually reinforces that magnetic field. And basically, you have created an electromagnet. Now, what happens when you bring 2 magnets close together? They repel, right? Unless the 2 poles are opposite, in which case they will attract. Well, what happens here is this coil is, oops, we're a little bit too high on the right-hand side. Let's move it back over here. Okay. So we have a magnet in our copper wire, but it's only a magnet if electricity is flowing through it. Now, if you remember, we removed part of the insulation. So half the time when this thing turns, half of the time it's touching metal on metal, electricity can go through it. The other half of the time, the metal is touching insulation, and it can't go through it. So this little magnet in the middle is constantly turning back and forth between being a magnet, now I'm a magnet, now I'm not. Now I'm a magnet, now I'm not. Since this magnet on the bottom is permanent, it will repel exactly when this thing is a magnet and push it. As soon as it gets far all the way around, if it didn't turn off, if the magnet didn't stop being a magnet, then it would just get stuck. Just like two magnets, you've reversed the poles, now the magnets are going to come flying together and it would stop turning. So we turn off the magnet and let it coast. It coasts for half a turn, and then all of a sudden it contacts the metal on metal again, and you get more electricity flowing through the coils. You turn it back into a magnet, and the magnet repels, and it pushes it away again. And that starts it turning. So it's because it's turning off and turning on, turning off, turning on. It's a magnet, it's not a magnet. It's a magnet, it's not a magnet. It's being pushed, it's being not pushed. It's being pushed, it's coasting. It's pushed, coasting. And it happens so fast and so quickly that to you and me, this looks like it's just a continuously running motor. Okay, and you'll notice what happens if I get my magnet a little bit closer, I should be able to get it to turn even faster. All right, so this is the video you're going to make. You're going to show me a video of exactly what I'm showing here with all the connections, and you're going to show me your magnet turning, the little copper coil. And if it doesn't work, it could be because it's not balanced very well. It could be you removed too much insulation, or you removed the insulation on the wrong side of the wire on either end, or you didn't remove enough insulation. So you're going to have to be careful and play with it a little bit. Try to get it as balanced as you can, but that's the project. That took me exactly 19 minutes to do, so that means it should take you no more than twice that long. All right, good luck. I can't wait to see your motors.